8 in 10 adults who have this do not know they have it. And the reason is not that they skipped their checkup. It is that the test they were given measures the wrong thing. It measures the result. It does not measure the effort. Today, insulin resistance and why the most common blood test in the world can look completely normal while it is happening. I am going to do 3 things: what insulin resistance actually is in your muscle, and it is more specific than you have been told, how it is measured, which turns out to be the most interesting part, and which of the everyday advice about it survives contact with the evidence, including several things I expected to hold up and which did not. Chapter 1, the quiet years. Here's the idea the whole episode hangs on. Your body is doing 2 separate things at once. There is the result, the amount of sugar in your blood right now, and there is the effort, how much insulin it is taking to hold that number down. A normal result does not tell you the effort was normal. It only tells you the effort worked. This is not my metaphor, it is how the CDC describes it. Quote, "The cells in your body do not respond normally to insulin. Your pancreas makes more insulin to try to get cells to respond. Eventually, your pancreas cannot keep up, and your blood sugar rises." End quote. More effort to get the same result until it cannot. Researchers followed 6,500 British civil servants for years and then looked backwards from the moment each person was diagnosed. Insulin sensitivity was already falling 5 years out. Blood sugar did not move sharply until the last 3, and in between, the pancreas was working harder, not less. The effort line moved first, the result line moved last. The scale of this is larger than most people think, and the number changed recently. As of the CDC's January 2026 update, 115.2 million American adults have prediabetes. More than 2 in 5, over 65, it is more than half. If you have seen a smaller figure quoted, that is the previous edition, and some official pages still carry it. Chapter 2, what it actually is. The textbook line is that insulin resistance happens in your muscle, your liver, and your fat. True, but it buries the important part. After a meal, about 80% of the sugar that leaves your blood goes into skeletal muscle. 80. Not your brain, not your liver. Your muscle is where this is mostly decided, which is going to matter enormously later. So how does sugar get into a muscle cell? There is a transporter that carries it across, and here is the part almost nobody mentions. That transporter is already inside the cell. It is sitting in little packages, waiting. Insulin does not create it. Insulin's whole job is to tell those packages to move to the surface and open. Insulin resistance is a failure of that message. The insulin arrives, it docks, and fewer packages move, so the sugar stays outside the cell in your blood, where it is easy to measure and where it does not belong. Your body's answer is to shout louder, make more insulin until enough packages move. That is the effort going up. Which works. For years, it genuinely works. Your blood sugar comes back normal because your pancreas is quietly covering the gap, and every standard test you are given is looking at the number that is being covered. That is the whole trick of this condition. It is not hiding, we are measuring the wrong end of it. One more thing before we move on, because it explains the rest of the episode. Insulin does 3 jobs, not 1. It moves sugar into muscle, it tells the liver to stop releasing its own, and it tells fat tissue to stop releasing fatty acids. Resistance does not hit all 3 equally, which is why one number was never going to capture it. Chapter 3, how you measure it. There is a real gold standard, and almost nobody reading this will ever have it. It is called the euglycemic clamp, described in 1979. 2 intravenous lines. One drips insulin in at a fixed rate, the other drips in sugar, and a technician adjusts it minute by minute to hold your blood sugar exactly level. The amount of sugar they have to pump in is the answer. It is, in the words of an NIH reference text, time-consuming, labor-intensive, expensive, and not feasible for routine clinical use. So it stays in research, which leaves everyone else needing a shortcut, and the shortcut everyone reaches for is a piece of arithmetic from 1985. It is called HOMA-IR, You take a fasting insulin, you take a fasting glucose, you multiply them and divide by 22.5. That is it. When the authors published it, they compared it against the clamp and got a correlation of 0.88, which sounds excellent until you read the next part, and the next part is in their own paper. Quote, from the 1985 paper that invented HOMA-IR, a single fasting sample taken in the outpatient clinic is unlikely to be a reliable guide to a subject's insulin resistance. End quote. The people who built the number wrote down at the time that one fasting blood draw is not enough. They also reported that repeating it on different days moved the answer by about 30%, which is why there is no agreed line. Watch this. The threshold researchers use for HOMA-IR is 1.55 in Thailand, 1.7 in Japan, 2 in Sweden, 2.77 in Italy and Brazil, 3.8 in France. And in one American study anchored against the clamp, 5.9, same test, same arithmetic, different lines. And underneath that is a problem almost nobody talks about. The insulin test itself is not standardized. When the American Diabetes Association put commercial insulin assays through a work group, the variation between different assays ran from 12% to 66% with a median of 24. Giving them all a common reference sample did not fix it. Your HOMA-IR partly depends on which lab ran it. So what does the guideline actually tell a doctor to order? The American Diabetes Association's 2026 Standards of Care names 3: a fasting plasma glucose, a 2-hour glucose tolerance test, and an A1C. Fasting insulin is not one of them. HOMA-IR is not one of them. They do not appear in the screening recommendations at all. The other shortcuts have the same problem. The triglyceride to HDL ratio is a popular one, and a cutoff of 3 came out of a study in 258 overweight adults. When researchers tested that same ratio in 98 African American adults, it performed at essentially chance. The author's conclusion was that in African Americans, it is not a reliable marker. A shortcut derived in one population does not transfer to another. And here's the cleanest demonstration that the measurement is the problem. Researchers put people through a 5% weight loss and tested them 2 ways. The standard glucose tolerance test showed nothing. No change at the 2-hour mark, no change in the total. The clamp on the same people showed liver, muscle, and fat had all become more responsive to insulin. 19 people. Same bodies, same week. How you measure it decides whether you see it. Chapter 4. What actually moves it? Start with the one that surprised me most. Remember the transporter that will not come to the surface when insulin asks? Muscle contraction moves it anyway, through a separate set of signals. Researchers biopsied the thigh muscle of people with type 2 diabetes before and after a single cycling session. The transporter at the cell surface went up by about 70%, the same rise as in people without diabetes. It went up in every single participant. How long does one session buy you? In the study that measured it with a clamp, insulin action was still better 48 hours later and back to baseline by day 5. That was 7 untrained men, so hold it loosely. But the guideline has quietly built its advice around exactly that window. The standards of care say do not let more than 2 days pass between sessions. The guideline numbers, and read the fine print with me, because these are written for people who have diabetes or are at risk of it, not as general fitness advice. At least 150 minutes a week of moderate to vigorous aerobic activity spread over at least 3 days. 2 to 3 resistance sessions a week on non-consecutive days, and 1 finding worth sitting with. In a review of 47 trials, being given advice to exercise on its own was not associated with any change at all. Now the part that ties this back to Chapter 3, and it is genuinely awkward. Exercise clearly improves insulin sensitivity when it is measured properly. But when researchers pooled the trials in type 2 diabetes and looked at HOMA-IR, the fasting number you could actually calculate at home, it did not move. The pooled estimate was slightly in the wrong direction, and the confidence interval ran straight through 0. Fasting glucose moved. The shortcut did not. The most elegant study in this whole episode is 30 years old. They had people train one leg and only one leg for 10 weeks. Then they measured insulin action in both. Same person, same weight, same diet, same hormones. The trained leg cleared glucose better, which settles whether this is really just about weight. It is not. And then the honest half. In the participants with diabetes, the difference was gone 6 days after they stopped. Weight still matters, and here's the most useful number I found. In the big prevention trial, every kilogram lost was associated with about a 16% lower chance of developing type 2 diabetes. Not a threshold you have to clear, a slope. The guideline target is 5 to 7% of your body weight. And the honest footnote, a separate trial in 5,000 people found the same intensive program improved almost every risk factor and did not reduce heart attacks and strokes. Sleep has the strangest evidence in the episode, and it is asymmetric. Cutting sleep to 5 hours a night for 1 week reduced clamp-measured insulin sensitivity by about 11% in 20 healthy men on a controlled diet. 4 short nights was enough to make fat cells themselves resist insulin in a study of 7 people. But then, this year, researchers did the reverse experiment. They gave short sleepers an extra hour a night for 6 weeks. Sleep health improved. Insulin sensitivity did not. Sugary drinks are the one dietary item where both kinds of evidence point the same way. In pooled cohorts, each daily serving was associated with about 18% higher risk of type 2 diabetes and 13% after adjusting for body weight. And in a feeding trial, 9 healthy young men drank fructose-sweetened drinks for 3 weeks. Their fasting glucose and fasting insulin stayed normal. The clamp showed their livers had stopped responding properly. There is chapter 3 again. And now the ones that do not survive. Cinnamon. A Cochrane review of 10 trials could not even pool a result for insulin sensitivity, and the current standards of care recommend against it. Vinegar does blunt the sugar rise from a meal, but 2 separate meta-analyses found no effect on insulin resistance itself. Berberine has better-looking numbers and, in the reviewer's own words, generally low methodological quality. That is a verdict of we do not know, not if it works. Detox programs. One trial included a group eating the same tiny number of calories without the detox, and both groups improved the same. And for molasses or seed mixes and insulin resistance, I searched the trial registry. 0 randomized trials, not weak evidence, none. So the short version. Insulin resistance is mostly a muscle problem, and the transporter it depends on is already inside the cell, waiting for a signal that stops arriving. Your body covers for it by making more insulin, which is why the standard tests read normal for years. There is no agreed threshold and no routine test. The guideline names 3, and insulin is not among them. What moves it? Training your muscle, protecting your sleep, losing weight in whatever amount you can hold, and drinking water instead of sugar. What does not? Everything on that shelf. If that was useful, subscribe. Next time, food and blood pressure. Which foods have real trial evidence behind them, and how big the effect actually is. This channel is education, not medical advice. Nothing here is a diagnosis. And insulin resistance in particular is not something to conclude about yourself from a number you calculated at home. That is the whole point of chapter 3. If any of this sounded like you, that is a conversation with your doctor. I am an AI presenter, and everything here is drawn from the sources shown on screen. Thanks for watching.